So my goal is to finish this within 30 to 45 minutes. That's my goal. And then for you guys to be able to have time to work on your Get More Math, because your Get More Math is focused on these particular topics. Write a function. Let's zoom in. What does it mean to write a function? What does that mean? Good. It means write an equation that models the relationship. Now, when it talks about a relationship, that's usually like y equals k times x and y equals k divided by x. Do you guys remember the names of these? One of them, one starts with a D and one starts with an I. Very good. All right. Oops, I missed the E on the inverse. Direct and inverse, K is the constant of variation. I'll point at K. Actually, no, I'll just write K is constant of variation. All right, and now I'm going to look and see what the heck's going on. Oh, we have all kinds of fun stuff going on. Okay, this is like a whole sentence, so it's not just direct or inverse. It looks like it's a combination of it here. All right, so we're going to read the sentence and then we'll interpret it as to what it means. So it says z varies directly with the cube of x and inversely with y. So just this red highlight tells us what to do. Let's start with, don't overthink this. How do we represent z? Z is just z. What did we say the word varies translates to? Equals k. Very good. What about the word directly? What did we say directly means? Multiply. C varies directly with the cube of x. What in the world is the cube of x? X to the third power. Some people think it's this, but that would be cube root of x. And inversely, what did we say the word inversely means? Division, good. With y. So y is just y. Now we're going to take that and we're just going to kind of mush it up together. So I will duplicate it like this, just like for the emphasis that I want to make. And I'm just going to kind of mash it all together. So I'm going to bring this x cubed over here with the times symbol. So it looks like that. And then I'm going to bring my divided by sign over and my y. I'm just going to clean that up a little bit. What would that look like if we cleaned it up? That's right. Keep k, keep x cubed, and then divide by y. If you want to, you can leave k out in front and like write it like that. Whatever makes you feel like more comfortable with the problem in and of itself. I personally write it like that. Okay, so that's the first step. I'm just going to write 1 because that's like step 1. That's like the single most important step. And then we read the next sentence. I'll highlight the next sentence in blue. Here's like the given information. This leads us to step 2. So z is going to get replaced with 100. X is going to get replaced with 3. And y is going to get replaced also with 3. So I'm going to go back to my equation. I'm going to find z, 100. What do you guys tell me what that would be? I'll go back to blue. Why don't you guys tell me what that would mean for like step 2? Yeah. So you correctly replaced z, x, and y with the things that it said to. All right, now step 2 is a little more involved because you have to solve for k. What would be your first step in solving for k? What do you think, John? First step in solving for k. Yeah, how do we isolate k? There's 2 things you could do. Multiply everything by 3. So if you multiply this side by 3, that goes away. Multiply this side by 3, we get 300. At the same time, I wouldn't mind if we just did 3 to the third power. Do you guys have 3 to the third power memorized? Not 12, 27. So I replaced, I just put it in the front. I like to have my coefficient in the front. You can write k times 27 if that makes you feel more comfortable. And then to solve for k, the last step would be Divided by 27. Whoops. Question mark 9, 10, 10 ninths. Nope, that's not right at all. That's embarrassing. 100 ninths. Thank you. Oh, I said 10 ninths. Oopsie. Oh, okay. I was silly me the 0. So that's just K. That is not the equation. The equation comes from step 1. But what do you guys think I do with K? Substitute in what? What do we get for K? Yep. No, because that's a great question. You can't use a decimal because mathematically speaking, you can't leave a decimal in a fraction. That would be considered something called a complex fraction, which is not allowable in math. So I replaced K. 300 divided by 27 math enters where the 100 or 9 came from. Replace K. Also, I did see, or some people asked me when we were doing this lesson, if they could write like 109ths. Oh dear, that's not what I meant. Here, I'll just show you what people asked and I'll tell you the answer is no. They asked if they could do it like this. And again, the answer is no, because you can't have a fraction inside of a fraction. So if you get a fraction, just put the numerator in the numerator and the denominator in the denominator. So when it asks you for a function, that's your function that you do. So you pretty much have to find K and fill it in. So steps 1, 2, and 3. I don't think they asked us to evaluate any further, so that's done. All right. Write a function that models the relationship. Let's do it again. I think we could probably just go through it without reading it because we already had that practice. What about Z? Z is, what does the word varies mean? Not just K, equals K. Yeah. What does the word jointly mean? No. Multiply. Jointly and directly both mean multiply. With the square root of X, what does that look like? Yeah, good. So not X squared, right? Like you actually do the root because it has the word root. And inversely, what does the word inversely mean? Let's see what we'll divide by. The square of Y. Oh, good. I tested your vocabulary here. What's the square of Y? Good. I'm going to clean that up, and then we'll go to the next sentence after we clean that up. So all together, that's going to be a Z, an equals a K, and then multiply with the square root of X. You don't have to write the multiply symbol if you don't want to, because it's implied. And divide by Y squared. So there it is cleaned up. There's step 1. Step 2 is a little more intense because we have to plug in all that stuff. I'm going to go ahead and duplicate it. And I'm going to erase the numbers and replace them with what they say. So Z is going to get a 2. I'll leave that there if you want to fill yours in. Z is going to get a 2. X is going to get a 16. Y is going to get a 4. And I made them have square roots on purpose. I'm going to go back and fill mine in. So Z is going to get a 2. X got a, did X get a 16? And Y was a 4? Do you think I have to put my Y in parentheses? I think it's a really good idea. Now, since it's positive, it's not a big deal, but if that was a -4 and you didn't use parentheses, it would at the end come out incorrectly. So it's not a bad idea to use parentheses. All right, so what would be the first step that you guys would take to kind of solve this or simplify? 4 squared. I would too. So leave K alone. And that makes 16. But what about, can you simplify the square root of 16? Yeah. I don't like how that looks. I would rather write 4K. Is that okay? You can leave it as K times 4 if you want. There are 2 steps you can take, both of which are fine. What would you guys do next? Times 16. That sounds like a good move. 2 times 16 is equals, divide by, and K is, yeah, good. All right, That's good. That was fast. Step 3 is to put that in for K. Go back to step what here? Go back to step 1. Yep. I'm going to go ahead and duplicate that. I'm going to take it over to the answer box. Then I'm going to replace it with 8. A lot of times what I see on this is people will just write in this answer box, they just write K equals 8. That's not the equation. They asked you for the function, so you need the whole thing. If they asked you for the constant of variation, you could write K equals 8. Because this is the equation based off of these numbers, but now I can use that equation for any values of x and any values of y to keep that same proportioned relationship. So like on the test, it might say, there might be like a part A, find the equation. Part B, hey, let's say this is on the quiz, find z if x is 36 and y is 7. So you would have to take that equation and fill in the square root for 36 and fill in 7 squared, 8 times 6 divided by 49, 48 over 49. So they might, this is extra, they might ask you to go further. But it is important that you get your equation first before you go further. Write the function. You can tell, these are things that I did 3 of them because I made this last year because I thought we needed it. So like there's 3 of these in a row for a reason. Okay, write the function that models it. Z varies. Okay, so what does Z mean Z? What does varies mean? What does indirectly mean? What do you guys think? That's also divided. And what am I going to divide by? X and Y, good. And then let's fill it in. So you can see I kind of sped it up a little bit. Fill in 4 for Z. Fill in, 1/8 for X and 2 for Y. What would you guys do first to solve for K there? 1/8 by 2. What did you get? A decimal's fine. Or a fraction, doesn't matter. 0.25, yep. And now how would you get K by itself? Good. I don't like multiplying by decimals because I always feel like my decimals look like time symbols. And what is 0.25 times 4? Very good. And then don't just write like K equals 1 in this box. The whole equation, Z equals 1 for K, then X and Y. And then if they ask you to go further with a new X and a new Y, go further with a new X and a new Y. All of that, actually all this whole first page, everything on this first page is from chapter 8, section 1. All right. Is this table direct, which is y equals kx, or inverse or neither? Inverse would be y equals k over x. Do you guys remember the test? How would you guys, in this equation right here that I have in this pink circle, how would you get k by itself? You would divide by x. That's because the test is y over x for direct. It's really an odd little thing, but you're just like trying to see if you can get k. What do you guys, how would you get k by itself here on this one? Multiply x. So the test is actually y times x. All right, let's go look at all the things that were given to us. And then neither just means like you don't get the same thing each time. Right off the bat, this one looked like a neither. I'd like to show you why though. If you did this y divided by that x, negative 3 point, okay. But if you did this y divided by this x, you get negative 8. So That's not what, because when we divided, we didn't get the same thing. We can write that it's not. What's the division test? Yeah, it's not. We tested this. You feel free to move to a different table. Since we tested division and it didn't work, we can say it's not direct. We would have to get the same thing each time. So I'm going to get rid of direct, and I'll change colors, and we'll try the multiply test. Nope, because yeah, when you multiply these ones, you get some 50, negative 80. And then, but these ones, when you multiply, you get negative 8. So you don't get the same thing again, which means it can't be inverse. Mm-hmm. And it might be good for you to see one that is inverse. I want you to be able to see one of each. So let me go ahead and pull that up. Okay. This one was direct because if you divide all of them, what do we get each time? See how when we divided them, we got the same thing each time? That made it direct. And then this one, when you multiplied them each time, you got the same thing. That made it inverse. So there's an example one in your notes, there's one of each. So if you need to go back and you're trying to figure out what it would look like, you can look at that. This one. Yes, okay. Oh, I circled inverse, but I shouldn't have. Did you guys circle inverse? You said it was not inverse. So it's neither. Okay. Be prepared that if it is direct or if it is inverse, to be able to provide the equation as well. All right. Oh, I'm excited. I love these ones. I love comparing graphs. It's one of my favorite things. All right. When we look at this graph, and we can compare it to this graph, is it reflected? It is not reflected. Why isn't this reflected from one to the other? They're both negative. If one was positive and one was negative, then we could say they're reflected. All right. So we can get rid of the reflection because they're both negative. Now we have to think about this one. How do you get from 0.5 to 0.7? What about like? Does anybody know like 0.5 times what number is 0.7? Yeah, let's find out. What is it? I need to look. I'm good. I think you're good. I just need to double check so I don't have my answer key sitting by me. 0.7 divided by 0.5. Good. 1.4. Yes, very good. Oh yeah, I guess that does make sense. Half of it, huh? So since it's what? Oh, let's math enter that. 7/5. Do you guys think that that is a? So you were able to say 1.4. So my question mark is 1.4. Do you guys think that 1.4 is a vertical stretch, or do you think 1.4 is a vertical compression? It is a stretch. And the decimal or the fraction form is 7/5. So let's look for that. Which one says vertical stretch by 7/5? There you go. Good. Stretch 7/5. Good job on the 1.4. And if you're on the calculator, I did 0.7 divided by 0.5. Feel free to move that sunspot. Okay. Do you guys think that these two, this one and this one, do you think they're reflected? Nope. What about this +2 in the back? What do we know about the +2 in the back? Up to. Let's find that one. Not down, not left. I see up 2 units. Right. It has to be D. D's the only one that has up 2. Now, if you're not sure about this compression part, you would do 0.4, which is the new one, divided by the original one of 1. So 0.4 divided by 1. And that's where the 0.4 is 2/5 comes up to be. Okay. So the number on the top got smaller. So compression. All right, now we go to number 7, which is a review from yesterday's information. Sketch it, find the domain and the range. You may use your calculator to check. I'm going to go through a couple things from yesterday, if I may, please. I'm going to ask you a few questions. Is this continuous? Or is it discontinuous? That's my first question from yesterday's assignment. It is discontinuous. Very good. Ooh, that's a horrible highlighter. There we go. Discontinue. I didn't do that right. Not necessarily. The reason this is discontinuous, discontinue. Now I feel like I'm not spelling discontinuous right. This is embarrassing. Is there an extra U in that? I'm really embarrassed by myself right now. There is an extra U. Okay. Yeah, there's an extra. I was like that. I didn't like that. Oh, there. That's how you spell it. That's better. Okay. That is discontinuous. Does anybody know the value that it's discontinuous at? Yes. Very good. How did you know that? Good. Yes. So you set your denominator equal to 0 and you see if you can solve. Well, how do we take, I just said it almost. How do you undo a square? And what is the square root of 0? Well, it's 0. So it is discontinuous at 0. My next question from you, and I'm trying to review yesterday and do this problem. Is that a hole, do you guys think? Or do you think it's a vertical asymptote? It is a vertical asymptote. Very good. Why is it a vertical asymptote? Good. Good. Doesn't cancel. Then maybe you're like, well, when would it cancel? If you had something like this, do you know that this x cancel with one of those x's? That would be a hole. But it's not. Ugly dougly. What about horizontal? I know this is like not actually, is it part of the problem? It's not, but it's not bad to study it. Horizontal asymptotes. I erased it off the board just in preparation for tomorrow's quiz. But where's the exponent bigger at? Good. So I'm not going to use the word exponent. What's another word for exponent? Do you guys remember starts with a D? Nope. Degree is bigger, larger, higher. I like higher. No, I don't. Is larger. In denominator. Yesterday, if the degree is bigger in the denominator, do you remember what the horizontal asymptote? I'm thinking in my head. I have it. It's just, that is something I study every year. Yeah. Yep. That's if they're the same. Then you do the ratio thingy. Mm-hmm. So if the degree is larger in the denominator, your horizontal asymptote is y equals 0. Okay. All that was just extra because really on this particular problem, since they're all different shapes, we can grab our calculator and we can type it in. -2 divided by x squared. And we can see that, but everything in that fits the shape. I know if I am droning on this problem probably longer than I need to. I'm just trying to make the connection for you yesterday. See this except x equals 0? That came from the discontinuous part. And you see that range where it says except y equals 0? That came from horizontal asymptote part. Hope that was helpful. All right, let's go to here. Find any holes, vertical asymptotes, horizontal asymptotes for the graph of the rational function. Hint finds the points of discontinuity, decide if they're removable or non-removable. Let's zoom in right here. Talk to me about the denominator. What do we always set your denominator equal to? Okay, and then we solve. How would I solve for this? Subtract 2 and square root of a negative. Is it real or imaginary? I'm just going to write no. That means when you get something that's not like that, like it's imaginary, does that mean it's discontinuous or continuous? That means it's continuous. In other words, there's no values of x that make it weird. There's no values of x that make the denominator 0. So that makes this a continuous graph. I don't even think that was part of it. Okay, so that if it's continuous, that means that it has no points of discontinuity, which means it has no holes, which means it has no vertical asymptotes. I think that's enough for us to say that the option what is correct. Yep. B has no holes, no vertical asymptote. Now I do want to talk to you about the horizontal asymptote. The horizontal asymptote was one that I had on the board over there. Tell me a little bit about the degrees. They're the same. So it's the ratio of their coefficients. So yep, 2 divided by, what's this coefficient on the bottom? 1. And 2 divided by 1 is 2. So that's where they're getting that from. So this is just a big fat NA. I think C was tricky. The negative square root of 2, but remember the negative was in the root, not outside the root. Yes. Sure. All right, next one. Let's look at the denominator because I think it's the same thing. Let's look at the denominator. I don't care about the numerator quite yet. Let's look at the denominator. Okay. Oops, sorry. Well, you didn't see the screen move, but the person probably heard it. What do you guys think about your denominator here? Set it equal to 0, and it can factor. I like that. So let's set it equal to 0, and let's apply what you said. Say it again. What did you say? It can factor. Let's see that thing factor. Go ahead, use those factoring skills. Do you guys need me to factor for you? Do you know how to factor? Good. X minus 1, x plus 4. Very good. Very good. And now, if you guys weren't able to get that fast, you would have to do A, C, B. And then I'm not sure if you guys are box factoring people or if you're grouping factoring people, but you would have to do that. Do you remember like how we would do this and we'd do like x squared minus 1x, x, we do 4x and negative 4. You would have to do that whole thing. Okay? I'll send you a video if you need one, okay? Just look at chapter 4, section 4 to review that. Chapter 4, section 4. All right. Now, what in the world does this parenthesis tell us? Yeah. Excellent. Good words. Very good word. 1, x equals 1 is a point of discontinuity. What about this one? Good. Set it equal to 0, solve. It's the same thing. Now, if you guys are struggling understanding that, I like how she said set it equal to 0 and solve. So like x plus 4 equals 0, x equals negative 4. And I also really like the vocabulary. Those are points of discontinuity. All right, so I have this little chart. If you like the chart, use it. If you don't like the chart, don't use it. I don't care what you do. I'll put it here. If you like the chart, I think I have one on the test for you tomorrow. There's your chart. We need to look at the numerator. The numerator was x minus 1. I need to rewrite this. X minus 1, x minus 1, x plus 4. There it is in factored form. Which one cancels? X minus 1. See, you don't even know, you're already on your way to being successful in Chapter 8, Section 4. Because that's all Chapter 8, Section 4 is. It's just factoring and canceling, factoring and canceling. Like factoring is like a super important part to the rest of Chapter 8. Oh, so which one of these came from the canceled? That's right. This one canceled out. I think canceled has 2 L's. If it doesn't, we're going to pretend like it does. It's fine. It's fine. Would you guys call that one removable or non-removable? And if it's a removable, is it a whole or an asymptote? What about x minus 4? Did it cancel? So removable or non-removable? And then I want to do the horizontal asymptote thing. I'm not sure if it asks for it. It does. I think it's important that we look at the horizontal asymptote. Go back to the original. Good. So when you look at the leading term here, you can see that the denominator has a squared in it and the numerator has a 1 in it. So since it's the degree of the denominator is larger, what did we say it is? Y equals 0. So I'm just going to write degree is bigger on the bottom. So it's y equals 0. Now it's a matter of just finding what matches. What do you guys got for me? Okay, cool. Okay. All right. Whew. Number 10, oddly enough, goes back to Chapter 8, Section 2. So I didn't mean to skip around, but like those problems just came from 8.3. This one comes from 8.2. Yeah. What middle x would I encourage you guys to use? Positive 2. Always pick the opposite of that for your middle number. And that will be for anything. That's for parabolas. That's for absolute values. That's for exponentials. That's for anything. Pick the opposite of that number to be your middle number. I like to go down by a half and then by wholes. That's just my preference. You don't have to use my preference. When I graded this one, I had my calculator beside me and I just typed in the x's you used to see if you did it right. I very much want you to use whatever x's you want. Go ahead. I love that question, and I'm going to do 2 things. I'm going to encourage you just to do this when you type in your calculator. Does anybody know? This is where, when I graded, this is where, like, if I circled yours and I wrote typed in calculator wrong, question mark, that's because maybe you forgot to do this in your denominator. If you don't put your denominator in parentheses, your whole XY chart's going to be wrong on your calculator. So I'm going to grab my calculator. I'm going to answer your question. And then I'm also going to just type it in with parentheses. All right. So your question is, how do you actually just use the fraction button? Let me see here. Someone taught. I don't do this often. Is this how they did it? I think they selected number. Did they select number? Ah, I can. Okay. So right here, I hit math. Somebody showed me this last year. I didn't even know this was a thing in the calculator. Math, and they went over to number. And then they went to option D as in dog. That will automatically tell your calculator, hey, I have a fraction I need you to make. And then you can type 3 in there. Maybe we could do, x minus 2 there. To me, personally, that's too much for me to remember. Like all those buttons. And I also don't like it because then you can't use any calculator. I would personally just do 3 divided by the quantity of x minus 2 and then add 1 like that. those are the same. Whichever way you can remember, that's the important part. Tomorrow when you take your quiz, please don't ask me how to get the fraction part, because I'll just say, please just use your parentheses. So make sure you're okay on your parentheses. To me, that's a better skill to have. Now, how do I get my XY chart from here? Unless you guys like plugging it in one at a time. Good. Yep. I have 0 as -1/2. I have 1. What I got? You can use whatever numbers. Maybe you didn't use my numbers. As long as you're able to graph it and you're able to pick it out, that's all that matters. And you definitely want to get an error there. That's good to get an error at +2. Five over 2 is 2.5. These graphs have, do you guys remember what's that? The A word. They have 2 asymptotes. They have a horizontal asymptote and they have a vertical asymptote. Do you know where each is? And it deals with this number in the back and then this number here. This one is your y equals asymptote. This one is your x equals asymptote, but it's the opposite sign. So if that's a -2, make it a +2. It's a +2, make it a -2. Now I'm gonna go ahead and graph those. So I'm gonna graph the asymptotes. I like to use, and you should mathematically use broken lines because they're not actually part of the graph. They're just things that they approach and don't touch. So I'm gonna make a vertical line at 2 and a horizontal line at 1. Vertical line at 2. Horizontal line at 1. Whoops. Oh, that's a bit. Why is that doing that? Okay. What you should notice now is that your points are going to come close to those asymptotes when we graph them, but they're not going to touch it. There's 1. And I can see that curve coming in to play. Drawing your asymptotes also allows you to get like approach where you're supposed to approach without crossing over. Get my other points on there. 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. There's 2.5. 1, 2, 3, 4. Right there. Ooh, I didn't like that. That looks silly. Oh, I went up 3.5. That's why. Whew. What about your domain? What did all the domains start with yesterday? All real numbers, but there was exceptions. That's right. And you can hopefully see how that related back to what we did yesterday. We saw our denominator, put it in. What about the range? This one's kind of odd, little duck. There is an exception, and it's kind of a weird little exception. What did we get here? That's right. Your asymptote is an exception. That's an exceptional asymptote. Okay. Boy, this isn't fun. I don't know what it. I actually thoroughly enjoy this. Like a puzzle. Like a game. No? Okay. All right. Find the points of discontinuity. Ooh, and decide if they're removable or non-removable. Oh, we're going to make a rational expression. Oh, that's fun. We're going to make the equation. Oh, that's really fun. Okay. If something has a vertical asymptote, you guys remember, is that removable or non-removable? Yeah, you almost have to like go back and you're thinking, good, non-removable. What about a hole? Is a hole removable or non-removable? I love thinking backwards. And it has a horizontal asymptote of y equals 0. Oh, this is cool. 3. Here's your fraction bar. You guys totally have this. If x equals 3 is a thing, what would be on the bottom? If x equals 3 is a problem, what would it have come from? Yes. Okay. And if x equals 2 is a problem, what would it have come from? Yes. If x minus 2 was removable, you would have another x minus 2 on the top. That makes it removable. And if we were to distribute the denominator together, are you guys good at distributing? What would that give us on the bottom? Uh-huh. Good. And our final answer, boom, 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 x minus 2. And then combine those like terms. Minus 5x. Now you might say, did we deal with this idea that there's a horizontal asymptote? What makes a horizontal asymptote of y equals 0? Do you remember? It was like option 1 on the board yesterday. Yes? Other way around, the bottom on top. And then like we already did that. By just like making the holes in the asymptotes, like we accomplished that goal of making the degree bigger. There's no horizontal asymptote when the numerator is bigger. All right. Is the relationship direct, inverse, or neither? So apparently I was up here and I must not have been happy that that was a neither. And I must be like, oh, I need to give them an example of one that's not neither. So I'm going to guess this one has to be something. I wouldn't have just doubled up a one for random. Did anybody notice a pattern? Like if you blank, then you get, what do you see there? 60 times 2. Yep. And yeah. Okay, so here's the question. They all equal 120. That's your K value. Now, you multiply to get the K value. That's a hard question. Does that mean it's inverse or does that mean it's direct? It means it's inverse. Yes. So it's y equals 120 over x. And that boggles kids' minds. Are wait, why is the equation division? Because how would you get this x to the other side? You would multiply it. So that to get that 120, that x has to be on the bottom so that when you move it to the other side, it's multiplication. That would be inverse. Suppose that what, I just love these problems. Suppose that x and y vary inversely. Okay, write a function, x is 1, y is 3. Write a function, cool beans. What do you guys think about just this phrase? Can anybody give me a generic equation for just that phrase? No, it's actually that. It's an inverse equation. To say that they vary inversely, which that means that like one will equal k divided by the other one. So you could honestly write x equals y over k. I just don't like writing x first. Now fill in 1 and fill in 3. And I filled them in appropriately. Like I put 3 in for y and 3 equals k. So we're kind of like step 1, step 2. What's the equation then? Yes. Y equals 3 over x is our equation. What should your middle x be? That one? What's your point of discontinuity? 0. Very good. I would choose negative 0.5, negative 1, and negative 2. You don't have to pick my numbers. I just like skipping by a half so I get a nice little picture and then skipping by a whole number after that. That's just my personal preference. Grab those calculators or however you want to do it by hand. I think I might, I think I can do all these in my head. I don't think I need my calculator on this one. 3 divided by let's see, can we do that? What's 3 divided by negative 2? 1.5. 3 divided by negative 1? Negative 3. 3 divided by negative 0.5 is negative 6. And this would be an error because you can't divide by 0. Positive 6, positive 3, positive 1.5. Feel free to use your table on your calculator. Ooh, the asymptotes. These all have asymptotes. Some type of weird thing that happens. Let me get my broken line. Do you guys know where the asymptotes are on this one? Yes. Yeah. It is. The first one is here at x equals 0. The second one is the number that we're being added to the back. 0. So they're both at 0. So in other words, just the axes. I'll go past the axes so you can see them. Nothing being added or subtracted to kind of throw us off. All right. Oof. Negative 2, negative 1.5. Negative 1, negative 3. Ooh, 4, 5, 6. Just getting that nice little shape in there. And get that kind of like curve. I'm going to type this in the calculator just so you can make sure you know how to type it in. Because like the graph will graph it on the calculator. It's just a matter of like typing it in properly. The equation would have been, let me get rid of these. 3 divided by x. You don't even need parentheses. It's 3 divided by x. There you go. And you can see that shape taking shape. Okay. So your domain is all real numbers except 0, and your range is all real numbers except 0. And remember the board over there, the horizontal asymptote? Where's the degree bigger? On the bottom or the top? On the bottom. Because this has essentially x to the 0 power. So we said anytime that you have the denominator with a bigger exponent, that's going to make your y equal 0 as your thing. Last question on number 13. What is y when x is 20? Yeah, you would just put 20 in right there for that x. What'd you get? So you would do y equals, remember how it was 3 divided by x? 3 over 20? That doesn't reduce. So it's just 3/20ths. You can put it as a decimal if you want. Is it a Nicky? I don't think it's a Nicky decimal. Is it? Is it just 0.15? So you can leave it at 0.15 or you may leave it at 3 over 20. Whatever floats your boat. Okay. I'm going to guess this one's a direct variation because I didn't give you one of those yet. But let's say it's in a bake sale, you record the number of muffins, S. Why would they use O? That should say the number of muffins, M. That's annoying. And then, I bet it was supposed to be, I bet I cut it off. I bet it was the amount of muffins sold and the amount of sales in the table below. I bet, because I did screenshots on this, so I'm going to guess I just cut out the word sold. That makes more sense. All right. Do you guys think that this looks direct or inverse or neither? Or maybe you just don't even know how to tell. Direct? Why are you saying direct? All right. So every time you do this, the y's divided by the x's, you are getting 2.75. Did you try everyone? Go ahead and just double check. Because if like these two are like significantly off, then we have to say neither. They're all 2.75. Okay. I was thinking they probably were, but I was like, I need to do my due diligence and make sure we check each one. Okay. So since the division worked, are we going to say it's inverse or direct? Direct. And direct is y equals, is it k divided by x or k times x? Yes. Even though the test is division, the equation is multiplication. And what did we just get for k? Yes, 2.75. Can anybody make sense out of that? Like, what would 270 in terms of this problem? That's why it works. That's right. What do you guys think about 275? Do you think that's like, that's exactly what it is? It's how much each muffin costs. It's the price per muffin. I do that a lot. I'm gonna really embarrass myself, but I do that a lot at like Walmart, like when I'm buying like paper towels or. Yeah, you do the unit price. So yeah, I was at Costco. This is so embarrassing, and like their coffee cups were on, their little coffee K cups were on sale, and so I just took the price, the WA, because I knew it was a direct variation problem. It's so nerdy right now, and I just divided by how many were in the box, and then I went to my Walmart app, and I like both of the coffees the same. So if that's big, it has to be the same quality. And I just did the price of that one divided by how many were in there, and so I just put my one back at Costco and hit purchase on Walmart. Okay. Yep. Oh, they don't want us to use Y. I'm sorry. What do they want us to use instead of Y? S. So that must be sales. 275. And what do they want us to use for muffins? Yeah. Ooh, I love part B. To make $275 in sales. What is that going for? Is that going for S? What is that? S for sales or M for muffins? S for sales. So 275 equals, and you probably could do that just instinctually in your head, but here's mathematically. So it got plugged in for S for sales. How do you get M by itself? Good. And you need, that's 100, right? 100 muffins. Okay. There's your review in a nutshell. Those are extras. You don't need to complete them. Please feel free to. If you want to complete them and email them to me, I'd be happy to do that. Your Get More Math this week is what I'd like you to work on now. I don't know if anybody wants to screen share their Get More Math.